Hello, young scientists. The scientific method. My name is Professor Benny. Science is a systematic way of learning about our natural world through observation and experiment. Whenever scientists want to find out about our natural and physical world, they use what we call the scientific method. The scientific method is a system of standard steps people use to answer testable questions. When scientists want to find out about our natural world, they use the scientific method. Here are the steps of the scientific method. The first step is to make observation and also ask testable questions. When scientists make observation, they ask a testable question. They pose a question. The next step is to state your hypothesis. Then after stating your hypothesis, you conduct a controlled experiment to test your hypothesis to see whether your hypothesis is true or not. The next step is to analyze and interpret your data or your results. Then finally, you draw your conclusion. Based on your data, based on your experimental data, is your hypothesis supported? So these are the steps of the scientific method. So the first step is make observation, ask a testable question. So now we are looking at the type of observation. We are looking at qualitative observation. When we talk about qualitative observation, we are talking about observation that uses our senses to observe the results. There are 5 senses. We're talking about a sense of sight, hearing, touch, taste, and smell. So qualitative observation is a type of observation that involves the use of any of our 5 senses. Examples of qualitative observation are as follows. It is green in color. So we can see, we can observe. So this is a qualitative observation. It has a sweet odor. When we taste it, we can tell that it has a sweet. When we smell it, we can tell that it has a sweet odor. So we use our sense of smell. The next example is it makes a rustling sound when rubbed. We can hear it using our sense of hearing. So this is a qualitative observation. The last example is it tastes sour. So this means we can taste it. When you can taste it, it's qualitative observation because we are using our sense of taste. Now let's look at the other type of observation called the quantitative observation. Quantitative observations are measurable and involve number or quantity. So when we talk about quantitative observation, we are talking about the type of observation that involves number or quantity. Quantity means the amount. So quantitative means we are looking at the number or the amount. They are made with instruments such as rulers and balances. So quantitative observation, you can measure using a ruler, you can use balances to take the observation. Examples are the mass of the apple is 15 grams. So we can use the triple beam balance to measure the mass of the apple. So this type of observation is quantitative observation. The next example is plan B is larger than plan A. If plan B is larger than plan A, this means that we can tell maybe plan B is 2 times as large than plan A. So this type of observation where we compare size is quantitative observation because we can compare to see whether plan B is maybe 2 times or 3 times bigger than plan A. The next example of quantitative observation is the height of the plant is 85 centimeters. So we can use a measuring tape or a ruler to measure the height of the plant. So this is quantitative observation because it involves number. The temperature of the room is 70 degrees Fahrenheit. This tells us how many Fahrenheit or how hot or how cold the room is. And we can use a thermometer to measure the temperature of the room. This involves number or quantity. So these examples, they are quantitative observation. The next thing we want to look at is inference and hypothesis. As young scientists, we should be able to differentiate between inference and observation. So when we talk about observation, to observe is to take a careful look at something using our 5 senses. Our sense of sight, hearing, smell, touch, and taste. We observe using our 5 senses. Making observation is a basic skill in science. But when we talk about inference, inference is drawing conclusion based on what you observe. So based on what you see, hear, smell, touch, or taste, you can draw a conclusion. And such a conclusion is called inference. Based on what you observe, what is your conclusion? So now let's look at some examples of observations and inferences. In column A, we have observations. In column B, we have inferences. So let's look at the first example. It says she's laying on the couch. So if you see someone laying on the couch, you can infer that she's probably tired. So that's an inference. You are drawing conclusion based on what you observe. The moon is out. When the moon is out, it's an observation. You can see when the moon is out. And when you notice that the moon is out, you can infer that it's probably nighttime. That's why the moon is out. You are drawing a conclusion based on what you observe. This is my favorite. He got 100 on the test. So when you see Marcus getting 100 on the test, that means he probably studied for the test. So you can infer that because Jane got 100 on the test, he or she probably studied for the test. That's your inference. It is dark outside. When you see that it's dark outside, you can infer that it's nighttime. So that's the difference between inference and observation. We observe using any of our 5 senses. But when we talk about inferences, we are talking about drawing conclusions based on what we observe. Now let's look at some examples. Let's do check for understanding. Let's see whether we'll be able to differentiate between inference and observation. So the diagram we see here shows rain falling on the tree and also the ground. We also have the rain gauge measuring the amount of rain falling. All right, so now let's look at whether these statements they are observation or they are inference. The first one, the rain is falling on the tree and the ground. So this statement is an observation because we can see that the rain is falling on the tree and the ground. We can use our sense of sight to observe this. The next one, the rain gauge shows 2.0 inches. The rain gauge we see here, it shows 2.0 inches. So this statement is an observation. We see that the rain gauge, it shows 2.0 inches. The next one, in 2 more hours, a total of 3.0 inches of rain will have fallen. So this statement is an inference. Based on what you observe, based on how the rain is falling, you can infer that in 2 more hours, a total of 3.0 inches of rain will have fallen. So this statement is a conclusion based on what you observe. So this statement is an inference. The last example is the air temperature is above freezing. When you observe that the air temperature is above freezing, this statement is an inference. This statement is an inference. The air temperature is above freezing. Now let's look at the next step of the scientific method. That is asking testable question. When we talk about a testable question is a question that explores the effect of one thing on another. So it's a question that explores the effect of one thing on another, meaning that the question should have 2 parts. cause and effect. Now let's look at some examples. The first example is, does the amount of sunlight affect plant growth? This question is testable because we have the amount of sunlight and we also have plant growth. If you have the amount of sunlight, will it affect plant growth? So you can test this question and give a plant maybe little amount of sunlight. If the plant grows another plant, you give it less amount of sunlight, then you can tell that this question is having an effect. This amount of sunlight is having an effect on how tall or how big the plant will grow. So this question is testable because it has two parts, the cause and the effect. Does living in space affect your height? So this means if you live in space, will you grow an inch or so taller? This question is also a testable question. Does the temperature of water affect how fast sugar will dissolve? So we are looking at the temperature of water. If you increase the temperature of water, will it affect how fast sugar will dissolve? So we have the cause and the effect. The last example is, does doing physical activity increase your heart rate? If you go to the gym, if you do physical activity, will that increase your heart rate? So this means we can test these questions. They have cause and the effect. So that's why these questions are testable, because they explore the effect of one thing on another. The next step of the scientific method after asking your testable question is to state your hypothesis. When we talk about a hypothesis is a statement that can be tested. It's not a question. It's not a response to a question. It's a statement that can be tested. So when you are writing a hypothesis and you bring a question mark, that means it's wrong. So we write hypothesis using this format. If blah blah blah, then blah blah blah, because then if you have a background information or background article or a data support it, you state it in because area. So let's look at some examples. If a plant receives sunlight, then it will grow taller because plants need nutrient to grow. All right. The next example. If you live in space, then you grow taller. So we have living in space and growing taller. So this is a statement that can be tested. You can send one person, you can send a person, maybe the experiment we did about Mark Kelly and his twin brother. Mark Kelly went to live in space for almost a year. Then after 1 year, we realized that we saw from the article that Mark Kelly grew an inch taller. So this is a statement that we can test. The next example is, if you increase the temperature of the water, then the sugar will dissolve faster. This is a statement that we can test. We can increase the temperature of the water to see how fast the sugar will dissolve. The next example is, if you do physical activity, then your heart rate will increase. In this example, you can have a group of students, you can have them do physical activity. Then you can also have a control group. They will not do any physical activity. Then you take their pulse rate, their heart rate, to see that after doing physical activity, their heart rate increasing. All right, so these are hypotheses because these are statements that can be tested. A hypothesis, remember, is a statement that can be tested. A hypothesis is not a question. It's not a response to a question. And we write a hypothesis using if-then format. You use if, blah, 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 then if you have a background information, you support it using because you are explaining your hypothesis. Why? Okay? So we write hypothesis using if-then format. It can be a statement. It shouldn't always be the if-then format. You can write it without being if-then format. But a hypothesis is a statement that can be tested. A hypothesis is a statement